When you look up at the night sky, it seems like the definition of peace, doesn't it? Silent swirling galaxies, the gentle twinkle of distant stars. But that beautiful tranquility is a grand illusion, because beneath that quiet veil is a reality of almost unimaginable violence. Our universe was forged in fire, and it's a place where cataclysms on a scale that defy human language aren't the exception, they're the rule. From the death of stars to the fury of black holes, titanic explosions are constantly reshaping the very fabric of reality. But how do you even start to measure that kind of power? To get a handle on the biggest bangs out there, we first need a benchmark, something a little closer to home. Imagine a force 1,000 times more powerful than the atomic bomb that leveled Hiroshima. Now picture it detonating not over a city, but over a remote, desolate forest in the heart of Siberia. On the morning of June 30th, 1908, that hypothetical became terrifyingly real. Eyewitnesses hundreds of kilometers away saw the sky split in two. A column of fire ripped through the atmosphere, followed by a wave of heat so intense they said it felt like their clothes were on fire. Moments later, a shock wave erupted with the force of up to 30 megatons of TNT, a blast that registered on seismographs all the way across Europe. This was the Tunguska event. In an instant, 80 million trees across 2,000 square kilometers of forest were flattened, their trunks all pointing away from a mysterious epicenter. And yet, there was no crater. The culprit, thought to be a stony asteroid or a small comet about 60 meters wide, had disintegrated in a colossal air burst miles above the ground. It was the single largest impact event in all of recorded history. But what if I told you that this earth-shattering event, this forest-flattening 1,000 bomb-strong cataclysm, is a mere spark compared to the cosmic firestorms happening across the universe every single day? Today, we're going on a journey from the biggest bangs on Earth to the single most powerful explosion humanity has ever seen. The Tunguska event set a fearsome standard for explosions on Earth, but it wasn't a one-off. Our planet has always been in a cosmic firing line, and to truly appreciate the scale we're about to explore, we have to look at the most devastating explosion our world has ever endured. Rewind the clock 66 million years. The planet was a lush, vibrant world dominated by titans. Dinosaurs roamed the continents, the undisputed masters of their domain. But from the darkness of space, an executioner was approaching. A 6-mile-wide asteroid, a mountain of rock and metal screaming through the solar system, was on a collision course with Earth. When it struck the shallow waters of the modern-day Yucatan Peninsula, the world changed forever. The impact released energy equivalent to tens of thousands of gigatons of TNT. This wasn't 1,000 times the bomb at Hiroshima. This was an explosive force so immense that it dwarfs the combined power of every nuclear weapon on Earth detonated at once. The initial blast vaporized water and rock, carving out the 200-kilometer-wide Chicxulub crater and blasting hundreds of billions of tons of dust and gas into the atmosphere. A global firestorm likely ignited huge stretches of forest, while the sun was blotted out for years, plunging the Earth into a deep artificial winter. Photosynthesis ground to a halt, food chains collapsed, and the reign of the dinosaurs came to an abrupt, violent end. It was the KT extinction event, a planetary cataclysm that wiped out half of all species on Earth. This is our benchmark, an explosion so vast it could rewrite the course of life on a planet. It's an almost incomprehensible amount of energy, and yet, on a cosmic scale, it's little more than the pop of a firecracker. To find the real fireworks, we have to leave our solar system behind. Out in the galaxy, the death of a single star can outshine the Chicxulub impact 1,000,000 times over. We're talking about a supernova. For a long time, astronomers thought these were the ultimate explosions in the universe, the gold standard for cosmic violence. Most stars, like our Sun, will die a relatively quiet death. They'll just puff off their outer layers and settle down as a dim, dense remnant called a white dwarf. But for stars born with much more mass, at least 8 times that of our Sun, a far more spectacular fate awaits. Throughout its life, a massive star is a constant battle. The relentless inward crush of gravity is held at bay by the ferocious outward pressure of nuclear fusion in its core. For millions of years, it fuses lighter elements into heavier ones. Hydrogen into helium, helium into carbon, and so on. But every star has an Achilles heel. For these giants, it's iron. Fusing iron doesn't release energy, it consumes it. So when the star's core gets choked with iron ash, the furnace suddenly shuts down. The outward pressure vanishes. In less than a second, gravity wins. The core collapses catastrophically, squeezing the mass of more than a sun into a ball just a few kilometers across. This superdense object, a neutron star, rebounds. It unleashes a shockwave of unimaginable power that rips through the star's outer layers, blasting them into space at a fraction of the speed of light. This is a supernova. A single one can briefly outshine its entire host galaxy of billions of stars. The energy is staggering. But these explosions aren't just destructive. They are the universe's primary source of heavy elements. The iron in your blood, the calcium in your bones, the gold in our vaults. Nearly every element heavier than hydrogen was forged in the heart of a dying star and scattered across the cosmos by a supernova. They are the creative engines of the universe, the violent deaths that make new life possible. For decades, this was the biggest bang we knew. But even this incredible explosion, an event that can seed an entire galactic arm with the building blocks of life, is dwarfed by what was to come. As our telescopes got better, they started to reveal a universe far more violent than we ever imagined. We discovered explosions that make a typical supernova look like a flickering candle. First came the hypernova. As the name suggests, this is a supernova on steroids. It's what happens when a truly colossal star, maybe 30, 40, or even 100 times the mass of our Sun, dies. The core collapse is so extreme, it doesn't just form a neutron star, it forms a black hole. As gas from the dying star swirls into this newborn black hole, it's superheated and channeled into 2 ferocious jets of energy that blast out from the star's poles at nearly the speed of light. If one of those jets were pointed at Earth, even from thousands of light years away, it could potentially strip our planet's ozone layer, spelling disaster for life on the surface. Then there are the magnetars. Take a neutron star, an object already so dense that a teaspoon of it would weigh 1 billion tons, and give it a magnetic field 1,000 trillion times stronger than Earth's. This is a magnetar, the most magnetic object we know of. This immense magnetic field is so powerful, it actually stresses and cracks the star's crust. These starquakes can unleash gargantuan flares of energy. In 2004, a flare from a magnetar named SGR 1806-20 reached Earth. Lasting for just a fraction of a second, it released more energy than our Sun does in 100,000 years. And while neutron star mergers are confirmed factories for gold and platinum, some new research suggests these magnetar flares could also be a major source, forging and blasting heavy elements out into the cosmos. Hypernovae and magnetar flares often announce themselves with something even more spectacular: a gamma-ray burst, or GRB. These are, pound for pound, the brightest and most energetic electromagnetic events the universe has to offer. For a few fleeting seconds, a single GRB can release more energy than our Sun will in its entire 10 billion year lifetime. Their discovery was a complete accident. In the 1960s, at the height of the Cold War, the US launched the Vela satellites to watch for the gamma-ray flashes of secret Soviet nuclear tests in space. The satellites did see flashes of gamma rays, but they weren't coming from Earth. They were coming from the deepest reaches of space, spread evenly across the sky. It was a profound mystery for years. It took decades of research to confirm these were the birth cries of black holes, the signature of a hypernova's jets punching through a dying star, or the cataclysmic merger of two neutron stars in a violent dance of death. For decades, the GRB reigned supreme, a brief, impossibly bright flash that could be seen from across the observable universe. It seemed we had finally found the most extreme explosions. We were wrong. The universe had something even bigger in store. The universe isn't just capable of brief, violent flashes. It can also produce sustained explosions so vast and powerful, they operate on timescales that challenge our understanding of physics. In just the last few years, astronomers have identified a new class of superluminous events, explosions that don't just last for seconds or minutes, but for years. These are the biggest explosions discovered since the Big Bang itself. They seem to happen when a massive object, like a giant star or an enormous gas cloud, wanders too close to a supermassive black hole at the heart of a galaxy. The black hole's gravity, a force beyond all earthly comparison, shreds the victim in what's known as a tidal disruption event. But when the victim is exceptionally large, the event gets supercharged. As the stellar guts spiral into the black hole, the explosion can outshine a powerful supernova by a factor of 10 or more and stay luminous for years. These events were astonishing, but they were just the prelude, the warning shot before the main cannon fired. In 2020, automated sky surveys picked up a new curious flash of light in a distant corner of the cosmos. At first, it didn't seem like much, but it didn't fade away like a supernova. It just kept glowing. And as more powerful telescopes were pointed towards it, astronomers realized they were witnessing something unprecedented. The event was named at 2021 LWX. Located nearly 8 billion light-years away, this explosion is, without exaggeration, the most energetic single explosion humanity has ever observed. It's not a flash in the pan. At the time of this script, it has been raging for over 3 years, and it's still detectable. Let's try to put its power into perspective. At 2021 LWX is 10 times brighter than any supernova ever recorded. It's 3 times brighter than the most extreme tidal disruption events we've seen. At its peak, it shone with a luminosity 2 trillion times brighter than our sun. The fireball itself is 100 times the size of our entire solar system. Now, some might point to an incredibly bright gamma ray burst like GRB 221009A, nicknamed the Boat, or brightest of all time. And it's true, for a few minutes the Boat was likely brighter. But think of it this way: a GRB is like a flashbulb. Insanely bright, but gone in an instant. At 2021 LWX is like a cosmic searchlight that's been left on for years. Because it has sustained its impossible energy output for so long, the total energy it has released is far, far greater. The leading theory is that this wasn't a single star being torn apart, but a colossal cloud of gas thousands of times more massive than our sun that got knocked out of orbit and plunged into its galaxy's supermassive black hole. The shock waves and energy release created a cataclysm that beggars belief. For now, it is the undisputed king. We started our journey in a flattened Siberian forest with a blast that leveled 80 million trees. From there, we witnessed the planetary cataclysm that ended the age of dinosaurs. We watched stars die and the glorious blast of a supernova, forging the very elements of life. We saw the universe's brightest beacons, the gamma-ray bursts, heralding the birth of black holes from across time and space. And finally, we arrived at 2021 LWX, an explosion so large its fireball could swallow our solar system 100 times over, an event so bright it shines with the light of 2 trillion suns, and so enduring it has lasted for years. We have journeyed from a terrestrial spark to a cosmic inferno, and the sheer scale is almost too much for the human mind to process. These discoveries are a profound reminder of our place in the universe. We live on a tiny, fragile world in a cosmos defined by forces of unimaginable power. But they're also a testament to human curiosity. From our quiet corner of the galaxy, we've built the tools to look across billions of light years and witness the death throes of stars and the fury of black holes. We are seeing the universe for what it truly is. Not just a place of silent beauty, but a dynamic, evolving, and endlessly spectacular show. And with every new puzzle like at 2021 LWX, we're reminded that the greatest explorations are still ahead. If you enjoyed this journey into the most extreme events in our universe, be sure to subscribe and turn on notifications for more videos about the wonders of space and astronomy. And let us know in the comments what cosmic mystery you'd like us to explore next. Thanks for watching.